talk, so the rules for these again are no calculator, try not to do any scratch work. When you think you know the answer, you put your thumb up, and then I'll call on you maybe. Hopefully there's quite a few thumbs up. And I may ask you to explain, I may not, so usually just after the answer, because you kind of got to keep moving, especially on a Monday. So here's the first one. X plus X equals 1/4. So you're trying to figure out what plus what will give me 1/4, and I put them together. Put your thumb up when you think you know. Okay, myself was together. Okay, so let's see if that's correct, 1/8. So if it's true, then it should make the equation true, and since there's two x's, I would have to do 1/8 plus 1/8. When we are adding or subtracting fractions, we are supposed to, or we can only really do it when we have a common denominator. Otherwise, we have to create one. Since this would be a common denominator, like the denominator will stay the same, and then you're just adding or subtracting the numerators. So what's 1 plus 1? And then this, when you simplify it, does simplify to 1/4. So when you divide the numerator and denominator by 2, it does simplify to 1/4. So yes, that makes it. So that's kind of tying into when we were completing the square, and we're trying to come up with like the same number that adds to a certain number. That's kind of like where that's coming from. I mentioned before that on your final, you will have fractions for completing the square problem, so be ready for that. This is like what's gearing you for is being able to do it even when there's fractions. So now here's the second one. 3/5 plus x equals 9/5. Put the thumb up when you think you know what x has. And we just talked about the fraction rules that you're hopefully seeing more about this time. 3/5 plus x equals 9/5. Hey, Philip, what you get? Okay, so let's see if that's true. And really, because our answer has it where it's the same denominator, we know whatever it's being added to should have the same denominator. And so really you're thinking what plus 3 will give me 9, and that would be 6. So yes, 6/5 for the x in the second one does make it true. Okay, now here's the next one. 3/2 squared. Put your thumb up if you think you know what the answer is for 3/2 squared. Squared. Okay, Tiana, what'd you get? 9/25, did I hear you right? Okay, anyone get something other than that? Riley? Nothing. Anyone get something other than these two? Ruthia? Alright, anything else? Okay, so you have a few ways you could go about this. One way is the power rule where if you have, and this only works for when it's division or multiplication in the parentheses, does not work when there's addition, subtraction in the parentheses. But the power rule says that if I have something raised to the power of 2, I can apply that to all the terms. So it's the same thing as doing 3 squared over 2 squared, which what's 3 squared? And what's 2 squared? So it should be 9 fourths. The other way you could have gone about it is knowing that raising something to the power of 2 means to multiply it by itself. So really you're doing 3 halves times 3 halves. And when you multiply fractions, that's pretty easy. You just multiply straight across. So like 3 times 3 is 9, 2 times 2 is 4. All right, any questions on that one? Okay, so then here's the last one of our warm up. Put your thumb up when you think you know what plus 1/12 will give me 1/4. What plus 1/12 will give me 1/4? What plus 1/12 will give me 1/4? What is 1/4 equivalent to? Okay. What did you say, Tiana? Did you say 4/12? No. So 4/12 is 1/3. 3/12 is 1/4. But really what I meant by asking that was like 0.25 or 25%. So then you think like, what's 25% of 12? Like if I cut 12 into 4, you have 4 increments of 30, right? 3, 6, 9, 12. So you could replace that 1/4 with 3/12. Like if I have to multiply by 3 to get 12 on the bottom, I have to multiply the numerator by 3. And then that should hopefully make it easier. I mean, you could also isolate the variable other ways, but this is probably the easier way. So now when it looks like this, what does x have to be to make it equal 3/12? 2/12. Or if you simplify it, 1/6. So again, I mentioned before, like, just because you don't remember all your fraction rules from elementary school doesn't mean that you are inhibited from being able to do all of this. Right now, for this exercise and the math talk, we're just like trying to get more fluent at it. That's why I asked you not to use a calculator. Really though, should you want to use a calculator, that would be the best substitute for not knowing your fraction rules. So say like I was trying to isolate the variable in the last one by subtracting 1/12 on each side. I can pull up my calculator, do 1/4 minus 1/12. It'll give you this long decimal. Are you guys looking here? I didn't see like many thumbs from any people, like certain people didn't put their thumb up at all. That tells me you don't know your fraction rules. And I'm telling you how you can size that fast, you need to that. Because like I said, you will have fractions on your test, like you can't just skip those problems. That's where too much of your grades do that. So like I said here, if you're isolating x by subtracting 1/12 on each side, this is what you could type in. Anytime you put a fraction in your calculator, use parentheses. So the calculator reads it. Don't round, especially when it's like a long decimal like this, that really goes on forever. Press that fraction button and it'll always give you the most simplified fraction for that situation. So like we got 1/6 or 2/12, same thing. Or same thing over here. You could do the 3/2 squared. Just again, put your fraction in parentheses, plug it in, press the fraction to decimal button or decimal to fraction button. And that's how you get the same thing we got without having to know all these little rules. Questions on that? All right. Reason why is because we are today looking at some more difficult problems in regard to completing the square. Like I mentioned, you'll have one on your final that is including fractions. So really, there's nothing new in this lesson today, other than you get to practice with some more difficult problems. Normally, like in the past, I've taught how to complete the square when A is not 1. But according to like my directions from whoever's in charge, I don't know how you want to phrase that. I don't have to at this level. It would be too much for you to learn right now. So when you are taking your test and you can solve a quadratic equation any way that you want, only save completing the square for when the leading coefficient is 1. Otherwise, use a different method. You could do factoring for other things when A is not 1. You could do quadratic formula, which I haven't taught you yet, but I will by the end of this week. So when it comes to completing the square, you can really, at this level, only do it when A is 1. In the future, you'll learn how to do it when A is not 1. I'm recording right now, just like always. It's always in the slides. Puzzle piece is lesson 13. You should expect to have your next quiz tomorrow over lessons 9 through 13. So make sure your notes are ready for those lessons, that your practice is done for those lessons, and that you genuinely actually tried to practice. Don't like just get the answers from someone else, because like I mentioned before, you need more than a 10% to pass the class, right? Don't just waste your time and then fail your quiz. All right, anyway, the binder check will be here before you know it. So if you've been absent, if you've not been making up the notes on your own, know that that's the expectation. There's the notes posted in Schoology. Today we'll probably only get through these 2 problems because it's a Monday and it's a short day. But in the past, I was able to do all of them. So do check out those notes if you want more practice. What else about that? And make sure you have your notes ready come binder check time. That will be May 8th. So not this week, but next week. Yes. Okay, so Thursday we learned how to complete the square. We did an activity to see why the steps are the steps that they are. So when I mention these steps today, there is a reason. Go back to Thursday's lesson and revisit that. I do think if you know the reason, then it makes it easier to remember. Because these steps, although they seem kind of random, are very intentional. And if you follow them exactly, then you will get the question right on the test. But you have to memorize the steps for the test. So open your eyes, either have your notes out from Thursday or rewrite these steps down. But what form does the problem need to be in before you can start? Say it louder. X squared plus bx equals c. Know that I did not write the a because right now the a is 1. For 9th grade completing the square, you're only doing it when a is 1. So it is not 1, then put it in the method. All right, the first step is to rewrite it into this. So this very first problem on your paper, how can I make it look more like this? How can I make like the parentheses go away? Philip, open your eyes. What'd you say? Okay, double distribute, FOIL, box method, but basically you need to multiply this out. And then you'll probably need to do something else to it to make it look more like this form. So write it into that form in step one. I'm really condensing these steps. We wrote them all out on Thursday. Step two, after that, whatever value is in the B place, you're gonna take half of it, so half of B. You're gonna square it. That's why I have it half first and then being squared, like the parentheses. And then you will add to both sides. So take half of B, square it, then add to both sides. What that does is it completes the square, so to speak. From there, you can factor the trinomial. And it should be the same number that's completing these two parts of the diamond. That's the whole point. That's what we mean by completing the square. We want to create a perfect square. And again, I'm really condensing these steps, so excuse me, I'm throwing out. After that, you are basically isolating x. So hopefully you know when you isolate a variable, you start with what's farther. So you will have to take the square root. And then you might have to add or subtract depending on the problem, but you're isolating x, in other words. Solving for both bases. Questions on these steps? And again, you're welcome to take out your notes on Friday if you want like the whole complete steps, but you should be able to multiply this out. That's a unit 6 skill. And then try your best to apply these steps to both of these problems. You might not get completely done with both of them, but that's okay. I'll check in with you in about 5 minutes. Just for those 5 minutes, you try your best to solve them. Four, this is a unit 6 skill, so hopefully like that's not still an issue. If it is, see me tomorrow after school, see me this Saturday and the next Saturday. Those are the only like last tutoring opportunities are Tuesdays and then those 2 Saturdays, and then that's really it. But multiplying this out was the first thing you needed to do. So table 6, what do we get from multiplying this out? Okay, good. So that's your first outer, inner, so like my outer and inner ended up being 1x minus 3x, so that's where we're getting the negative 2x from. And last is how we get the negative 3, and the 5 was already there. So all we did was multiply it out to make it look a bit more like the form it needs to be in for completing the square. Table 1, what else do I need to do to this to make it look more like the required form? Add 3 to both sides. Because for completing the square, they want the constant terms on the other side. They want the x squared and the x term alone on one side. All the single numbers on the other side. You cannot just like, I don't know, do 5 minus 3. You have to cancel it out on one side and then do the same for the other. So then 5 plus 3 is 8. Questions on that first step? Now from here, we are taking half of B, table 2, what's my B value right now? What number is in the B position? Just negative 2. So does that make sense, you guys? Got it? So this is where B is always in front of the x term, not the B dot number. Okay. So half of negative 2 is what, table 2? And then we're gonna square it, table 3, what's negative 1 squared? And then we're gonna add it to both sides. Why, you might ask? That's what makes this a perfect square trinomial on the left side, is when we add a 1. Think about that activity we did where we set up our diamond and you were trying to think what two numbers add to -2, our b value. That would be -1, but then it has to square to get to the constant. If you just apply that rule, then now you'll always have a perfect square trinomial on the left, and then whatever you do on one side, you have to do for the other to keep it equal. So 8 plus 1 is. Now step 3, we factor. And what you should be getting at this step is the same two numbers right here and here that multiply to 1 and add to -2. What are they? -1 and -1. And what I've noticed is it's always whatever half of b was, right? It's supposed to add to the bottom. So it's always whatever half of b was, but otherwise just think logically what multiplies to 1 adds to -2. And we want to write it in its condensed form. So that's the perks of having a perfect square is you can write it like this. Now instead of having two separate x's that I can't combine otherwise, I have just one and then I move on to step 4, which is isolating it. So table 4, what's opposite of squaring something? Philip, open your eye, look alive. What's opposite of squaring something? Square rooting, whatever we do on one side. So that will cancel out the square. X minus 1 equals class, what's the square root of 9? Plus or minus 3, so don't forget, moving forward, anytime you square root, there's technically the two situations it could have been. +3 and -3. Both giving 9 squares. All right, now keep isolating x with opposite of subtracting 1. Whatever you go on one side. And don't forget, most of the time quadratics have two solutions. This is how you get the two solutions. By doing +3 plus 1, what's that? And -3 plus 1, what is that? Okay, good. That's our solution for the first one by completing the square. Any questions? And although I know you probably didn't get to the second one, just now apply what we just went over again. Is it in the form that it needs to be in for completing the square? Does it have the, okay, it has the x squared and the x term alone on one side and the constant on the other, so that step's already done for us. We just move on to step 2 now, which is to take half of b, table 5, what's my b value in this problem? Oh, so I'm gonna take half of 1/2. You guys know what that is, great. If you know how to multiply fractions, great. I'm gonna show you again on the calculator because that's accessible to everyone, whether you know your fraction rules or not. Half of 1/2. Half of 1/2 is 0.25, but we want the fraction 1/4. So half of b is 1/4. We're now gonna square it. Table 6, what is 1/4 squared? 1/4 squared, what is it? 1/16 is correct. Because again, you could apply the power rule, or you can just type it in your calculator and look to tell me 1/16. So that's me doing half of b squaring it. And now we need to add it to both sides, the 1/16. Everyone with me so far? So that makes a perfect square trinomial on the left. On the right, what's 3/16 plus 1/16? And although we could reduce that, let's not until the very end. Any questions? Added it to both sides. Alright, step 3 is to factor, and although like these are fractions and you might not like it, you might not easily think of what multiplies to the top and adds to the bottom, you kind of already went through that when you did this. 1/4 times 1/4 will give me 1/16. 1/4 plus 1/4 will give me 1/2. We already went through that thought process when we created this. Does that make sense? So now I can write it like this: x plus 1/4 in parentheses squared equals 4/16, and I can just continue to isolate x. What's opposite of squaring? Square root. Whatever you want on one side. Now, again, you could use your calculator for this part, but when they're both perfect squares, that kind of makes it easy. You just take the square root of the numerator and denominator. What's the square root of 4? What's the square root of 16? And then the left side is just x plus 1/4. And really, I should have done the plus or minus, so let me squeeze that in front of the 2/4. Because anytime we square root, there's a plus and a minus. Okay. What's opposite of adding 1/4? And whatever you do on one side. And don't forget to solve for both cases. That's why I always sometimes I forget. I remember I should normally have 2 answers. So what's positive 2/4 minus 1/4? And this next part I might have to separate so you can see it better. But what's a negative 2/4 minus 1/4? Negative 3/4. And again, you can use your calculator to subtract the fractions, but this is basically what you'll have to do on your own. Solve by completing the square. You do not have to skip problems with the graph. Questions? And that's all we have time for. There's 10 more on your note sheet. It's all worked out in Schoology. If you want to go take a look.